Okay, in this video I want to talk about something called continuously compounded interest, and this carries over from what we talked about in the last video. In the last video we looked at what happens when n changes, and we saw that it was kind of diminishing returns. And so even if we compounded interest infinity times in a year, that doesn't necessarily mean that I'm going to get infinity dollars, because we kind of have this diminishing returns property happening. And kind of a way to see what's going on there, why this is diminishing returns, is as the number n gets bigger, this denominator gets bigger, and so this guy is getting smaller and smaller and smaller. The fraction becomes really small. And so the thing in parentheses looks really close to a 1. It gets closer and closer to 1. On the other hand, the exponent gets bigger and bigger and bigger, and so it looks like an infinity. And so we kind of have this dueling battle of 1 to any power should be 1, so it should be small, but anything to the infinity power should be really big, and so which one wins? And so it's somewhere in the middle is what ends up happening. And I want to kind of investigate this a little bit more closely in this video. Okay, we need some room to write. I'll keep some of the highlights because we will come back and mention how this ties into what we already calculated, but I do need some room to write. Okay, so what I want to do is look at this formula and play with it a little bit. Mainly, I'm going to play with the exponent. So I'm going to write the exponent as n over r times rt. And hopefully you believe that this is the same as what was originally there, because if I divide by r and multiply by r, those two things should cancel out. Okay, now I'm going to do another thing. I'm going to change the letters. Let m be n over r. So if m is n over r, then that's the thing I just made it. This is an m, and this r over n is actually m upside down. So this is actually p times 1 plus the reciprocal of m raised to the power m times r to the t. Okay, one other thing I'm going to do, I'm kind of using weird rules of algebra and arithmetic now. I'm going to put an extra set of parentheses in there. And bear with me, but if I have a power of a power, then I'm supposed to multiply the exponents, so these two things do mean the same thing. And so what happens is when n gets bigger and bigger and bigger, since m is n over a constant, m is going to do the same thing. And as m goes to infinity, this thing in the brackets, that's the kind of dueling battle of the 1 to the infinity power that I mentioned. 1 plus 1 over m to the m power, as m gets bigger and bigger, is actually going to approach a particular constant. It's going to get really close to the number 2.7182818284845.9. Okay, that's incredibly random, but so is pi, and it comes up in a lot of places. So this number inside the parentheses, as n, the number of periods gets more and more and more and more, gets really close to a particular constant that we're going to use the letter e to represent, lowercase e. And so this is going to be constant just like pi is. But what I'm saying is the thing in brackets turns into this number e. And so if I'm compounding interest infinitely many times, or continuously compounding interest, I don't even stop for every second, I just keep calculate, then this is the formula we're going to end up with, which is actually kind of simpler than what we started with. We have a constant, p, we have this number e, which if you stare at your calculator, you should have a button for e in your calculator. And then the exponent is r times t. And so I don't need n at all. It just, if it's continuously compounded, it's p times e to the rt. So let's take a look at the example from the previous video using continuously compounded interest. And so in the previous video, we said that p was 1,000, R is 12%, and T is 3 years. So Let's plug those numbers into this formula. If I'm compounding interest continuously, we have 1,000 times e to the 0.12 times t, which is 3. So I need to find the e button in my calculator and do 1,000 times the e button raised to the power of 0.36, or 0.12 times 3. And what I get is 1,433 and 33 cents. So I mentioned in the last video that we kind of have diminishing returns, and now we're definitely seeing diminishing returns. 24 to 33, we only gained, is it 9 cents? Yeah. Not much. Okay, so when we increase from 365 periods in a year to infinitely many periods in a year, I'm not earning a lot of extra money. At least in this example. Keep in mind, we mentioned before, if the principal is very large, then you would expect it to be a larger change. Also, if the number of years is very large, if I leave $1,000 in an account for 30 years versus for 3 years, I would expect there to be a bigger difference between these different things. But again, we do have diminishing returns. When I increase from monthly to daily, it's not going to be a huge change. Okay, so that was kind of our introduction to the number e, which kind of just pops up in this really weird way when I'm looking at compound interest, but it turns out it's also going to pop up kind of naturally in other situations.